So we will continue our discussion on coordinate geometry. So this is our fifth lecture. Okay, so we have started off with straight lines, and we have discussed about general equation of straight line, right? Then we discussed about slopes. Okay, we have discussed about angle between two lines. Okay, then we discussed about the concept of parallelism and perpendicularity, and I told you two lines are parallel when their slopes are same, or m1 and m2 are equal if m1 and m2 are the respective slopes of line L1 and L2, and two lines are perpendicular if the product of their slopes is going to give you -1, -1. Okay, so that's what we discussed in the previous session, and we stopped at the condition of perpendicularity. Now in this session we are going to look at some more different cases. So let me start off with the case of equation of a line which is parallel to x-axis. Okay, so when I say equation of a line which is parallel to x-axis, within that there are three possibilities, right? Equation of a line parallel to x-axis which is on the positive side of y and on the negative side of y. Okay, and it can be on the x-axis itself. All are parallel to x-axis. So we will see three cases. So I hope you understood what I am saying, right? See, this is the first case. If this is my xy, I am talking about the first case. This is line. Second case that I have discussed is this is x and this is y, and on the negative side. Okay. Third case that I discussed is on the x-axis. That means on this itself, that line. Okay, so these are the three cases that we need to discuss. Then after that we'll discuss equation of line which is parallel to y-axis. Again you will see same three cases. Okay, so when I say equation of line parallel to x-axis, which automatically mean this line is perpendicular to y-axis. Let me show you that. Okay, so I am taking, this is my x-axis and this is y-axis. Okay, so I am taking a line which is parallel to x-axis. Okay, so this distance is fixed and this is b. Let me mark it as B. So this is your origin 0, 0. So this is B. Now on this line, see, this line is actually made up with a lot of points, infinite number of points, right? This is 1 point, 1 point, 1 point, 1 point, like this. There are many points. Okay, so all these points are actually giving you line. If you take a point here, let's take this point here, and x coordinate of this point, this is A, and then this is A comma B, right? That is A comma B, or I can write it as XA, x1 comma B. Similarly, if this so this length is anyway b only, this length is anyway b only, that length is not changing. Okay, that height is not changing. That means the y coordinate is not changing. Y coordinate is fixed. It can assume any value for x coordinate. Okay, so whatever be the, it can be negative value. If you take it here, this is going to be -ab or -xab. Okay, so you can, it can be, let's suppose this point is C, then this is going to be CB. Okay, it can give you any values for your x coordinate by y, but y coordinate is the same. What is that? Y coordinate is B. So the equation of this line is basically, it is irrespective of x coordinate, because x coordinate can take any values. Okay, that will satisfy the equation. Only thing is here y must be equal to B. So this is the equation. The equation of a line which is parallel to x-axis, I don't want to talk of x because any value of x will satisfy this. Okay, so this I can put x 100. Okay, so if this is 100, x is 100, the y coordinate will be b. If x is -100, still y coordinate will be b. Okay, so x is y equal to b is the equation. Now three cases. First is this b greater than 0, right? B greater than 0. So here you can see b greater than 0, that is on the positive side of y-axis. So this is the equation, y equal to b, if b greater than 0. Now if I simply ask you, see, I have a line, okay, I have a line parallel to x-axis. Okay, so I tell you that I have a line which is parallel to x-axis, and I give you what I tell you is, okay, see, without drawing the coordinate, let me draw the line, and I tell you this line is parallel to x-axis, and this is crossing a particular, and I'm giving you one of the point of that axis. Okay, let me tell you this is 2 minus 3, 2 and -3. So what does this mean? I told you already this is a line parallel to x-axis. So if I put this as +3, -3 I'll discuss next. You clearly understood this equation of this line is y equal to b, y equal to 3 here. Okay, because any point if you take, y coordinate will be 3. Okay, it can be -3, then y coordinate will be 3. X coordinate can be anything, so this is not important for me. Similarly, if it is -3, you will write it as x is y is equal to -3. Why? Because see, that is the second case, right? The b is negative. B is less than 0. Then how will your line looks like in the Cartesian plane? It's x and y. It will be like here. Okay, so this is your line L. So this distance is b, that is minus b. Anyway, length can't be negative, right? So I can't write distance as negative, so this distance is always positive. But when I write the coordinates, the y coordinate will be always negative b. It can be a. Now y coordinate will be, it can be 100 and b, minus b. Here minus 100 and minus b. So the point is, y coordinate is always negative because the distance is b, and that is to the negative direction, right? So my equation of the line will be y equal to minus b. And now there is nothing to discuss here. If it is on the line, if it is on the x-axis like this, if I am getting my line on the x-axis, y equal to 0. Y equal to 0, because there is no distance from x-axis, right? There is no distance from the positive side and from the negative side. So the distance is what you need to write. The distance from x-axis is what you need to write if the line is parallel to x-axis. Distance is b on the above side, okay, on the positive side, so here y equal to b. Distance is b on the below side, that is on the negative side, y equal to minus b. Distance is 0, then y equal to 0. Okay, now clearly you can see this line is perpendicular to y-axis. So either I will tell you parallel to x-axis or perpendicular to y-axis, both are same. Here also you can see perpendicular to y-axis. Here also you can see perpendicular to y-axis. So what we discuss now is equation of line parallel to x-axis and perpendicular to y-axis. 3 cases we have done. Similarly, we need to discuss now equation of line parallel to y-axis and perpendicular to x-axis. Okay, we are going to see that now. So again there will be 3 cases. So if you take this is my x and this is my y-axis. Okay, equation of line parallel to y-axis means it is perpendicular to x-axis, so I can draw the line like this. Okay, now the distance here is, I can mark it as a, like what we have seen in case of b before. Okay, and this is on the positive side, right? Now if you take any point here, you take any point, your x coordinate will be this distance. X coordinate will be this distance, so it can be a 100 or a negative 100. X coordinate will not change. Okay, so your answer is going to be x is equal to that distance, which is a. Since this distance is on the positive side, positive a. What if I am talking about a line on this side? Again the same distance I am taking, this is a. Distance can't be negative, but it is on the negative side. So the coordinate will be, x coordinate will be minus a. You can take minus 100 as y coordinate, but a coordinate will be minus a always. Plus 100 as your y coordinate, okay, but still your x coordinate will be minus a. So what is your answer? X is equal to minus a. Now what is the third case? Third case is the line which is lying on the y-axis. Here it is parallel to y-axis because on the y-axis, and it is perpendicular to x-axis because it is on the y-axis, right? So distance is 0 here, so you can write it as x is equal to 0. So these are the 3 cases which you need to discuss here. So parallel to x-axis and parallel to y-axis. Parallel to x means automatically perpendicular to y, and parallel to y means perpendicular to x. So I hope you understood this much. So if the distance from the, see, perpendicular to y means, okay, the distance is b. So if I am saying distance is b, if it is on the positive side, y equal to b. If it is on the negative side, y equal to minus b. If it is on the x-axis, y equal to 0. Here, if the distance in the positive side is a, x is equal to a. Negative side, x is equal to minus a. On the y-axis, x is equal to 0. I hope this is clear for all of you. So this is the equation of line which is parallel to x-axis and parallel to y-axis. Now we need to see some other equations of lines. Okay. Now we need to see different forms of equations of straight lines. Okay. So we'll see different forms. We will see slope-intercept form. Okay. Or first we will see point-slope form. So you will be getting 1 point and a slope. Okay. Then you will see 2-point form where you will get 2 points. With that you can find the slope and you can get the answer. Okay. Then you will see X-intercept form, then you will see Y-intercept form, then you will see intercept form, you will see normal form. Okay. All these things is what we are going to see now. And after discussing all those things, I tell you how can you transform to all these forms from the general form, which is x plus by plus c equal to 0. Okay. So let me start off with point slope form, where you will be given the slope which is m, and you will be given point p which is x1 y1. Okay, so let me take a straight line here like this. Okay, so this is my straight line, this is my x and this is my y. Okay, so the slope will be given, that means theta, tan theta will be given, right? So m is given, or tan theta will be given, or theta is given, you can find tan theta and you can get m, or you can get the slope. Okay, so that is there. Now I'll be giving you one point. Okay, so the point I'm giving you is x1 y1. Okay, so this is my point Q, and your point P is x comma y. Okay, so I just gave you the slope of the line and I just gave you one point on the line. Okay, now equation will be, generally if you need to get if you have the equation, once you put these 2 points, the equation have to be satisfied, then only I can say that is the equation of the straight line, right? Now how are you getting this? Okay, now let me ask you, how will you get the slope? If you remember, before we have done this, you drop this and you drop this and you join the triangle and you know how to get the slope, right? And you got it, right? When 2 points are given, let's suppose 2 points are given, how will you get the slope? Slope m is equal to y minus y1 divided by x minus x1. This was your slope, right? Now what you can do is take this to this side. So what you get, y minus y1 is equal to m into x minus x1. Okay, and this is the equation of the line that I'm talking about. So if you are given m, so this is known to you. You are given a point, that means y1 and x1 is known to you. You can get the equation. Just substitute y1, x1 and m, you will get the equation of the straight line, and this is what we call as point slope form. Okay, so the point slope form you can get once you know the slope and once you know the point. One point is enough. Okay, now next we will move on to 2-point form. Okay, so point slope form is completed, so now 2-point form. So 2-point form means 2 points will be given. In the point slope form, one slope and one point is given, so here 2 points will be given. So if I take my straight line like this is my point Q and this is my point P. So P being x1 y1 and Q being x2 y2. Okay, so this is given to you. Can you find the straight line? See, you already understood y minus y1 is equal to m into x minus x1 as the equation of the straight line if 1 point, okay, and slope is given. Now here you know 2 points. Okay, now can you find the slope? That is the question. See, once you know the 2 points, you can find the slope that we have already discussed. What is slope? Slope m is equal to y2 minus y1 divided by x2 minus x1, and that's your slope. Okay, so now it is crystal clear that you got the slope. You got 2 points also. Okay, so what is your answer going to be? You can write this as y minus y1. Substitute in terms of m, y2 minus y1 divided by x2 minus x1, okay, into x minus x1. What we did not do anything extra. We just got in the previous equation point slope form. We know if we know slope, we can get that, but slope we can find by using these 2 points. So we are finding the slope and you are writing the expression. Okay, so it's just an extension of the previous equation only. Okay, so here this is nothing but your m. Okay, and then the equations are actually same. Y minus y1, x minus x1, m. That's it. So point slope form and 2-point form are actually same, or rather 2-point form is an extension of point slope form. Okay, now next we need to discuss about slope-intercept form. Okay, so one slope will be there, one intercept will be there. Now intercept means what? See, intercept means when line is passing through like this, okay, this much on the y-axis, this is what we call as y-intercept. Okay, take the y-coordinate, you'll get the y-intercept. So you get a point here. So if that point is x1, y1, take y-coordinate, that is y1. So y1 is this height, right? y1 is that length or the height, that is what your y-intercept. And this distance, you can mark it as x2, y2. Okay, so x2 is this distance, right? So that is your x-intercept. So x2 is this is your x-intercept. I hope you understood. So here one of the intercept will be given. Okay, so let's try to understand how you're going to find the equation. So first I'll discuss about the case of y-intercept, because that is most commonly asked and more useful. Then we discuss about x-intercept also. Okay, so y-intercept. Now y-intercept is given means let's suppose this is the 2 intersections, okay, on the x-axis and y-axis. Y-intercept I am giving you this as 0 because x coordinate is 0 here, and c is the y coordinate. So clearly you can see what is the intercept. Intercept is c, y-intercept is c. I am not giving you x-intercept. Okay, so if x-intercept is known, then you know y-intercept and x-intercept, and we have a intercept form. That is different. Here slope and intercept. Okay, now slope means this theta will also be given. right? When I say slope-intercept form, slope will be given, one intercept will be given, and I'm talking about y-intercept. So y-intercept is given and slope, that is theta, is given, right? So how will you get this? Once theta is given, okay, you can find tan theta, which is equal to m, that's your slope. Okay, now once this is known, y-intercept is given. What does that mean? Automatically one point is given. What is that point? Point represents 0, c, where x coordinate is 0, y coordinate is c. So in the previous equation that you have seen, y minus y1 equal to m into x minus x1. See, this is also extension of the point slope form only, okay, because we know the slope, we know the point. Point we know in terms of x-intercept because that point is lying on the y-axis. That's it. That's the only difference. Earlier that point was lying anywhere. Here the point is lying on y-axis, so we use the y-intercept. Okay. Let's see how we are going to get it. Okay. Now y1, that is your c. So y minus c equal to m into x minus x1 is 0. So m into x. Okay. Now take y to the c to the other side. So y become mx plus c, and that's your equation. So the equation of straight line, okay, which is cutting the y-axis at c, that means that y-intercept is c, is given as y equal to mx plus c. Okay. Now see, in the same case, if I tell you the line is passing through origin, then I am giving you y-intercept here. X-intercept is also there, that is also 0. Okay. So y-intercept clearly is 0. Now if I give you the slope, I give you the slope also. That means theta. That means I know m. Okay, so I told you that this line is passing through origin, then the c is going to be 0, right? Because y-intercept. See, this equation, this m is what? M is the slope. C is what? C is the y-intercept. And how you got this y-intercept? From the coordinates which is given, from the point which is given. Okay, so once you got the point, you just see what is y. Okay, you get that it is c. Just put that in slope into x plus c. You get the equation. Here, when I talk about this, slope is given, intercept is given as 0, so c is going to be 0, so y equal to mx is the equation of the line which is passing through origin. Okay, now all the lines which is passing through origin will have equation mx. Yes, equation mx, but what we need to know is m will vary, depends on, see, this is theta, so this will be theta 1. So based on theta 1, this will be m1. So what does that mean? Y equal to m1x, m2x, m3x. So various slope, you will get various equation, right? So y equal to mx is one line, this is the line. Y equal to m1x is this line, which is with respect to theta 1. But y-intercept is 0 already. So I don't have a c here. Okay, I don't have a c here. Okay, now next, again one more point if you take. If you see this case, line which is parallel to x-axis. We have already discussed this case. I told you the slope is 0 in this case. Okay. Now line is parallel, that means slope is 0. So in my equation y equal to mx plus c, I have given you slope is 0. So the intercept will be given because this is going to be c. Okay, let's suppose this is 0, c. So I have been told you, I may not tell you slope is 0. I just tell you equation of a straight line which is parallel to x-axis at a distance of c, or equation of a straight line which is parallel to x-axis and one point will be given. That point can be 0c or 1c or whatever it is. You just need to know that y-intercept is c. Your answer is going to be y equal to c. I told you this already. Why? Because why you are getting this is because m is going to be 0. Once m is 0, this x part is missing. Okay, that's it. Now what about in case of x-intercept? Okay, see, you can clearly see if x-intercept is given like this. I'm telling you this point is a, 0. Okay, and I give you the angle also, obviously, then only you will get tan theta and m. So I'll be giving you m and I'll be giving you this point. Okay, once I give you this point, I understood that x-intercept is a. Why? Because x coordinate is a. Okay, once this is 0, I know this is cutting the x-axis at a. If I simply tell you a and 1, a comma 1, okay, then I can't do this because then it is at some other point, right? A comma 1 is a different point because this is a, correct, but I am talking about point here. Y has to be 1, but here y need to be 0, then only it will cut the x-axis, right? So a comma 0. So x-intercept is a. So in my equation that I have discussed first, point slope form, y minus y1 equal to m into x minus x1. Just substitute for y1 and x1. We know y1 is 0. So y is equal to, this is 0, m into x minus a. So this is the equation. Okay. Passing through origin, we already got it, right? Passing through origin, we already got it. Here also you can just substitute a equal to 0. So y equal to mx. That's what exactly you got already. Okay. So that's done. Now perpendicular to x-axis or perpendicular to parallel to y-axis, we have already discussed, right? That is x is equal to a. Before we discussed y equal to b, here x is equal to a because this distance is a. Okay, so these are the three cases that I need to discuss here. So I hope you understood this. Now next type we need to discuss is intercept form. Okay, so in intercept form I will be giving you two intercept. Okay, so two intercept means, in fact I'm talking about this point and this point. So let's suppose this point is this distance is b, so this is on the y-axis, so x is 0, so 0 comma b. Okay, and this is on the x-axis, so y is 0, so a comma 0 if this distance is a, if this distance is b. So in fact I am giving you 2 points on the line, so you can use 2 point form, you can get the slope, and then you can use point slope form and you can get the answer. Okay, so what is your points? Okay, so 0 comma b is one case and a comma 0 is another case. So you got 1 point, second point, use point slope form or 2 point form, you can get the answer. Okay, now if you ask me how will you proceed, see, you can start with 2 point form because 2 points, so y minus y1 equal to y2 minus y1 divided by x2 minus x1 into x minus x1, right? So which is equal to y minus y1 is 0, okay, equal to y2 is b. Okay, so this is point, second point, this is the first point, that's how I am considering. Otherwise also it's fine, ultimately you will get the same. So b minus 0 divided by 0 minus a, okay, into x minus a. Okay, so you will get y equal to b by minus a into x minus a. Okay, so this 0 is not there, this is not there, this is not there. So b minus a, that's what this, x minus a. Now when you cross multiply, you will get bx plus ay, okay, equal to ab. Now what you can do is you can make this right hand side 1, so divide by ab. So you divide by ab, divide by ab, divide by ab. So what you get, x by a plus y by b equal to 1. And this is the equation. Okay, so this is what I am talking about, equation of a line, the intercept form. So what is a here? A is the x-intercept. What is b here? B is the y-intercept. Okay, so this is x, this is y. So like you can see here, this is the y-intercept and this is the x-intercept. So once this is known to you, you can directly write. See, if you need to write in the intercept form, your answer, you don't want to think of all those things. 2 points are given. If you need to represent this in terms of intercept form, x by a plus y by b equal to 1. That's your answer. Okay, because y-intercept and x-intercept is known. This is x-intercept and this is y-intercept. That's it. Okay, so if I generally tell you one equation like 3x plus 4y equal to 12 or 3x plus 4y minus 12 equal to 0. This is the equation of a straight line. I don't know whether it satisfies the conditions or not, but anyway, just assume this is a straight line because I told you any first degree equation in x and y will give you a straight line. This will definitely give you a unique straight line anyway. Okay. Now what you can do is, if somebody is asking you what is the x-intercept and y-intercept, there are two methods in which you can find it. Put x equal to 0, get the y-intercept, then put y equal to 0, get the x-intercept. That is one way. Secondly, what you can do is, you can write like this, 3x plus 4y equal to 12. Okay, then make it into this form. Make the right hand side 1. Right hand side 1 means divide by 12, divide by 12, divide by 12. Once you divide by 12, you will get this as 4, this as 3. So clearly you can write easily 4 is your x-intercept because this is in the form of x by a. Now this is x by a, right? X by 4 and y by 3. So 3 is your y-intercept. And that's what you get when you substitute x is equal to 0. When you put x is equal to 0, what will happen? 4y equal to 12, y equal to, what you get, 3, and that's what y-intercept. Similarly, when you put y equal to 0, 3x is equal to 12, so x is equal to 4, and that's your x-intercept. So I hope you understood. So what all things we have discussed today is, we started off with straight line, we have seen concepts of slopes, we have seen angles, okay, we have seen condition of perpendicularity, parallelism, okay, then we moved on to understanding the types of, or the equations of various types of equation of straight lines. We started with point slope form, we discussed about 2 point form, okay, and then we have discussed about what this case, right? What is this case that we discussed now? intercept form, right? In between we have discussed X-intercept and slope, Y-intercept and slope. Okay, so 5 types we have discussed. We will continue in the next session. So if you have any doubt, you can drop a message. Okay, so see you guys. I hope all of you understood this. Okay, and I'm expecting that you're following this regularly. So stay tuned. I'll be discussing more of this coordinate geometry, and we'll discuss all the shortcuts towards the end of the session. Okay, so now I'm focusing on understanding and the basic concepts. Conceptual clarity is more important, right? So we'll discuss shortcuts towards the end of the session. Okay, so see you guys.